let's take a look at a couple real life examples of how we can use scientific notation. It says light travels at a speed of 1.863 times 10 to the fifth miles per second. Wow, think about that. 1.863 times 10 to the fifth miles per 1 second. Want to know how far does it travel in a year? Well, we know that it travels 1.863 times 10 to the fifth miles in 1 second. If I write this as a rate, I want to know how far is it traveling in a year. Well, first of all, we got to change seconds into years. So if you think way back to the beginning of the year where we did some unit analysis, we can figure out how many seconds are in a year. I know that there are 365 days in 1 year. And I know that in 1 day, there's 24 hours. So if I multiply these together, that'll tell me how many hours per year. If we keep going, I know in 1 hour, there are 60 minutes. So I'm just going to keep going until I can figure out how many seconds there are. I know in 1 minute, there are 60 seconds. Okay, so with these all canceling out, this big number I'm going to get up top is going to tell me how many seconds per year. So if I multiply those together, I get 3,153,000. Actually, I apologize, that's not right. Let me try this again. 365 times 24 times 60 times 60 is 3,153,6,000. 31,536,000 seconds per 1 year. Now, since I'm dealing with scientific notation, I'm going to take a little liberty here and change this into scientific notation. I'm going to say that this is approximately, if I move my decimal point over 1, 2, 3, 4, 5, 6, 7 times, I'm going to say it's about 3.15 times 10 to the 7th. Yes, I could write 3.6 here, but we're talking about such a big number, that's okay if we're a little off. So again, just so I can keep it in similar format, again, I could have changed this all into decimal format and left it like this, but then you're just dealing again with bigger and bigger numbers and it gets confusing. So I'm going to stick to scientific notation. Okay. So now what I'm going to do is I'm going to say, all right, this is how fast it's traveling in 1 second, and there are 3.15 times 10 to the 7th seconds in 1 year. If I multiply those together, that's going to tell me how many seconds there are, how far it travels in 1 year, how many miles in a year. So remember, just like the problem we did in another example, you can kind of switch this up and multiply your decimal parts and then your exponent parts. So if I go 1.863 times 3.15, I get approximately 5.8, we'll say 87, it's like 86845. And then if I look at 10 to the 5th and 10 to the 7th, same base being multiplied, I can write it as times 10 to the 12th. And that is how many miles it's traveling in 1 year. If we move this over 12 times, that's how many miles it is in 1 year. So I would say it travels a very, very long distance. So again, sometimes we're going to have to figure out a conversion factor or do some unit analysis, but the focus again is on when you're multiplying numbers in scientific notation. Since it's all multiplying, you can switch up the order. Multiply your decimal places, multiply your exponent parts, and use your exponent rules to get your solution. One more example. In 98, the population of the world was about 5.9 billion. In the same year, the population of the U.S. was 2.7 times 10 to the 8. What percent of the population was the US population. So remember, we're talking about percent. We're talking the US population out of the entire world. Well, the US population was 2.7 times 10 to the 8th. The world population was 5.9 billion. Billion. That's like saying 5.9 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So, again, percent, part out of the total. So if we keep doing these problems like we practiced in the past, divide this out. 2.7 divided by 5.9. Oh, is going to be approximately 0.4576, we'll stop there, times 10, I'm going to subtract their exponents, times 10 to the negative 1. Now we're looking at percent here. So my advice to you is to change it just into a decimal number. Negative 1, I'm going to move it 1 to the left. So this becomes 0.04576. Now, I know it seems kind of weird we're moving it to the left, but now let's move our decimal point to the right 2 places because we want a percent. So percent means we move it to the right 2 places, and this becomes approximately 4.576%, or maybe we can just round it to 4.6%. So what percent of the population was the US population? About 4.6%. Again, setting up problems and then using your knowledge of scientific notation and exponent rules to solve them.